Hello my friends, welcome to Inside Out Electronic channel. This is Uncle Misha, and today we will try to fix this magnifier lamp. So it's a really nice lamp. I was using it a lot. Actually I have 3 of those, and one of them actually started giving up the ghosts. So this is CFL light bulb, as you see, a very good actually quality one. It has very nice CRI. As far as I mean, if you trust the user manual or the product description, has a very nice CRI. And actually, I was one of my earlier video was actually shot using 2 of these. So they are actually very good quality. I like them. So obviously there is a CFL bulb, so that's sort of old school right now. These ones are made with LEDs. So what's happening here? So this start flickering and shutting off randomly. So there are 2 possibilities. Light bulb is Gonski or started to go. Another possibility is that there is electronic components which are here. They are start to go Gonski. There are a few possibilities what's going on right here. I'm just guessing. We're gonna actually opening this stuff and gonna check. I'm guessing that there is a capacitor which actually getting old and there is an issue with it. And for some reason, for this particular unit, this part will start getting warm. So I assume this is actually a capacitor. We will try to locate it and take a look. I'm gonna show you how it looks like, then I'm gonna wait some time to discharge the capacitor and I'm gonna continue, or actually short the capacitor, depends. So let's try to power it up. Okay guys, so now this thing not even lighting up at all. So yeah, it was flickering a little bit before, now it's completely gone. So let's power it down and let's measure what's going on here. I just realized that disconnecting this thing from the rest of the arm will be a little bit of a challenge, so I'm probably not gonna do that. So I'm gonna be just doing all my work. This thing attached to this boom arm, yes, and it's not lighting up anymore. I'm kinda surprised why, but whatever. We still have to fix it no matter what. So let's try to unscrew 12 screws. And to my surprise, this lens is actually glass. I thought this is all molded one piece of acrylic, but this is actually glass. It's amazing. Okay, so let's go in here and what do we see? Okay, we see high voltage power supply with transformer or choke. This is clearly reminds me about some of the CFL bulbs I was disassembling earlier, and a few possibilities that could happen here. Number 1, the filaments are Gonski. That's possibility. This capacitor is Gonski. Okay, this one, but highly unlikely. So let me remove the light bulb right here and measure resistances of those filaments right here. So it had this pretty cool socket. I never actually seen this before, but this is how it was connected. I just yanked it, and now let me check resistance. I'm not sure what these metallic thingies are for. They're not really holding it in place, they're just wibbly wobbly. Okay, switch my multimeter to the ohms mode and let's measure. So I assume, so here are 4. We have 4 pins right here, right? So I assume those 2 is one side of the tube and those 2 is another side of the tube. And let's just measure them. Measuring something, but not nicely. Okay, it measures 4.3 ohms, which is highly likely correct. 6.5 ohm. It's interesting there is a difference in resistances. What is the resistance for sure? Because I don't like this huge difference. Okay, that's better. So 6.9 ohms. Okay. Okay, so next step, look, I assume the light bulb is fine. So next step would be to unscrew a little bit more and check other components. Looks like this light bulb or light fixture actually replicates the very typical layout topology of a CFL bulb driver. Okay, this is totally look like that to me. So we have little transformer right here, and we have choke right here. This is not transformer, it's a choke, I think. Okay, so few possibilities. We have this capacitor Gogonsky. We have the fuse Gogonsky, but it is not. Let me measure the fuse, but like the fuse is highly likely fine. Yeah, fuse is fine. Let me check. First to check voltage. What do we have? All discharged. Yeah, I just wanted to see if there is any voltage on the capacitors or anything like that. Just make sure they are discharged. Okay, let's measure the voltage on the big one. No, it was 32 volts. It still has some voltage, as you see, guys. Yeah, 32 volts. Okay, gonna safely discharge the capacitor by shorting it with my lead, and now capacitor is discharged. So this is Yelicon, obviously high quality capacitor for sure. It's 22 microfarad, 200 volts. We're gonna check this little gentleman here. I don't see any other obvious damage, so I need to check those transistors, but typically if transistors are gone, we have either short, most cases short, and it's actually quite volatile at this kind of voltages. So yeah, good it has a fuse and actually this fusible resistor. It's really good. So let me check my ESR meter, take my ESR meter and see what we got here. Okay, we have our ESR meter. Let's try to measure ESR of this capacitor. Okay, what were you saying, my friend? It's saying actually okay. 4.6 ohm for 22 microfarad. Well, it's supposed to be 1.8, judging by this, here a little diagram right here. It's supposed to be way lower than that. For 22 microfarad, 250 volt. This guy is 200 volt. Supposed to be lower than that. Okay, we can pull this guy out and check also his capacity. Let me do that too. I hope this gentleman measures capacity, but it has a limit, so I think it's 30 microfarads. So I'm gonna pull this out and see what we got. So here we are. Cup is out, and there is a little blob right here. I see, not blob, but dry joint. I'm gonna resolder it. Nah, I thought it was fine. Okay, let me check this capacitor real quick. Okay, capacitance mode. This is discharged. Hello? Okay, looks like we have a problem. Okay, oh yeah, by the way, let me measure out of circuit this capacitor. This is not too bad, but the capacity Probably this guy is not good for capacity. Let me take something else. Well, another tool in my basket. This goes. Let me see. What do you say? Take some time. No, that's fine. Yeah, 2.21 microfarad, 5.3 ohm ASR. Alright, so the capacitor is good. Capacitor is good, so let's put it back in. So what's next? Let me see what could be next. Alright guys, so before we start analyzing what our issue is our circuit right over here, let's take a look at schematics. So this is not exact schematic of this particular lamp. Let me move it a little bit closer. It's not the same, obviously, because I just found it on the internet, and I think this is pretty close. It has this choke, it has obviously the bridge, a capacitor, filtering capacitor, it has fuse, it has resistor, and all requisites like right here, fusible resistor and saying this is pretty close. And this light bulb is 23 watt. 22 watts, this one is for 20 watts, so that's pretty close. So transistor is gonna be very similar. Really hard to tell what kind of transistors here, but the little transformer, and I think, does it have another output choke? I don't think so, but nevertheless. Oh, here, it's here, right here, so of course it's big. There's not transformer, this is choke, so this choke is right here. So I'm not the big expert in CFL light bulbs, but judging by my experience, what's failed pretty often is, well, in addition to, like, first of all, the light bulb filaments fail, okay, and due to physical damage, stress, or just being too worn off, so they fail. Then obviously everything just stopped working. But in our case, we tested our filament of both filaments are fine. So we tested and both of our filaments are fine. So second candidate is this capacitor right here. As you see, we have two. Why? Because in between those slits you can have pretty high voltage, and as you see, the voltage of capacitors is doubled and capacity is obviously is halved. So in this particular case we have pretty much 1250 100 1260 volt capacitor right here. Now we have to see where is that capacitor, like this capacitor, in this schematic. So we're gonna check it first, because well, then we're gonna check other components, but we're gonna check, we don't see any busted resistors, we don't see any busted transistors, so visually I assume this is not those components. Fuse is fine, everything else is fine. So now I have to okay, so we have the C5, because it's really hard to read, and we have this, what the heck is this? Yeah, because they turned opposite direction and I don't see the values. Damn. So C6 and C5. So now I have to like trace it and to see what is what. Looks like our culprit is, potential culprit is this C5, C6. C6. But the same story goes for this capacitor. It has to be checked as well, but this is the main thing, so we have to check this guy first, then we're gonna check this guy second. So this one is no, actually it doesn't matter. This value is obviously going to be different. We just use this schematic as a reference. Then if this is checked out, we're gonna go down this line. So we're gonna put it aside, and let me in order to check those capacitors, unfortunately I would have to desolder them. Actually this guy doesn't matter because it's essentially floating, right? So I can try use multimeter to check this cap here, and then I have to check this capacitor as well. Let me take my capacitor meter and see what you're gonna get. So now I'm gonna take my fluke in the capacitance measuring mode and see what we get. Okay, so this guy measures 7.6 nanofarad. All right, this guy measures pretty low. Wow, it's actually in picofarads, like... Okay, obviously we are measuring in circuit, so it could be like who knows what values. This is consistently measured 7. Okay, so in order to understand what the heck is going on here, I have to unsolder these guys. So let me do this. I already have my soldering iron handy right here. So this... It's not easy to get them. I'm gonna use this pokey thing to actually pry this capacitor while I'm unsoldering it. Alright. Okay, one lead is out. Let's try to do... Okay, so where are you? So this capacitor is out, and I'm probably gonna take this out as well in same attempt. Okay, this was easy too. Okay, let me shut it down and see what we have. So we have our two capacitors out. So here we are. So this guy is actually of the correct voltage, is 1250 volt, and its reading says, let me zoom, okay, trust me, I don't want to zoom in, 68.2. So this guy is 6.8 nanofarad. So let's measure again. And I think we are fine on the... let's use this guy. I have this lovely capacitor tester. Let's use this guy. Let's plop our capacitor right here, like this. Hope it's making contact. No, it's not. Testing, and it's testing. 69.25 picofarad divided by 1000, we have 6.9 nanofarad. You don't see that. Wow. But trust me, this capacitor checks out. Nice. Let's use this capacitor, which shows some weird picofarad values. Whatever, forget about calibration, my friend. Okay, it's testing. And it reads 192 picofarad, and it's supposed to be 15 nanofarad. I think it's 115.3. So yeah, it is 15 nanofarad. So this capacitor is substantially lower than it's supposed to be. It's a 630 volt, but judging by schematic, this capacitor doesn't have to be as high voltage as these two, right? Or this one compound capacitor. So potentially we found the culprit, but not where we thought. So this is not capacitor in between filaments here, not this guy. It is this guy is bad. So we have to replace it. You have to replace it for something else. The problem is to find some suitable replacement right now. It's going to be probably funky. I do have some spare box of light bulbs, of CFL light bulbs, busted ones, so I have to dig through them, but who knows, maybe their capacitors is busted as well. So let me dig through and see what I have. Alright guys, after poking a lot, I found lots of interesting capacitors. For example, here is replacement 6.8 nanofarad for this guy, right? But I don't need it. I need something like that. So with my whole bunch of different these guys, I cannot find suitable replacement of 15 nanofarad. So here is 47 nanofarad, and the thing is, I think it could work because this particular light bulb is 23 watt, which is similar. Like, I mean, it's not the same, probably needs higher voltage or something, but it might work. I'm gonna just give it a shot, literally, and if it's not working, I mean, it's not working, or if it's gonna blow it up, whatever, it's still not working. So I'm gonna replace this capacitor, this 47 nano, instead of 15. Okay, and obviously this guy will go back as well. Then, if no, I'm gonna search or buy particular like the capacitor like that, but this means that this video would be delayed. Oh yeah, and before we plop this capacitor in, let's just test it, and it reads 46 nanofarad. Even ESR is here. Okay, so capacitor at least is more or less operational. Okay, so we have our new temporary capacitor in, and the original 6.8 nano back in as well. So let's just connect it. I'm gonna use it just like that. Yeah, I don't think. Okay, let me think how was it. Was like that, so let me just do it right here like this. Yeah, just to have the right orientation. Okay, so and let's just test it. Power it up. So what I'm gonna do, I'm gonna quickly test it, not gonna just keep it running. Okay, well, I thought it's off. Okay, now it's off. And obviously, you saw it working, but yeah, here we are. So clearly our little culprit is this little guy. So this capacitor is bust, and hence it was not working. So now obviously I have to wait while all this jazz discharges before I actually start poking around and assembling it. Alright my friends, so here is our patient is assembled together, and obviously we're gonna give it a test, and it is working. So I did order proper capacitors. In the meantime, I'm gonna be using it like this from time to time. I'm not gonna be pushing it just to make sure that capacitor is not gonna cause excessive current or some other things which are not good for this lamp not designed for. Proper capacitors already are already ordered. So guys, yeah, I think it was a successful repair, and I'm happy that we was able to analyze it and figure out that this little capacitor is a culprit. If you like this sort of videos, please subscribe to my channel. This helps support it, help it grow. Have any comments, please fire it up. We'll be happy to hear from you. And thank you for watching. See you next time. Ciao. Stay safe.